I think I'd be in the habit by now. But you're given two functions, and we're going to call them f, and the other function is going to be g. The composite function is f, and then we're going to put in square brackets of g of x. So what this means is that you're plugging g of x into f of x. So instead of just plugging in a number or plugging in a variable, you're plugging in an entire function. Now, we've already done this, so just a reminder, we found f of x plus h clear back in chapter 3. Well, what we were really doing with that x plus h is that would have been the other function, g of x. So we've been doing this. We've been doing it when we did our farmer and our fencing problems by picking up the perimeter function and plugging it into the area function. So this is not new. We've been doing it. We just haven't labeled it before this. The problem is that this notation of f of g of x is a little awkward. So we come up with a new notation, and our new notation is f, and then you're going to see a little circle that looks like a degree symbol, like degrees Celsius or degrees Fahrenheit, but it's written down in the middle of it. And then you'll see the g, that'll all be in parentheses, and then you'll have the x. So this little symbol right here means compose in mathematics. So it simply means compose. So this is f compose g of x. So when you look at it, it almost looks like the word fog. Well, if I can pick up g and plug it into f, then I can also go the opposite direction. So we also have, get rid of the extra stuff, g of f of x. So that would be g compose f of x. So this one looks like golf. So it's the fog and the golf functions we kind of refer to them too. So here you're picking up f and plugging it into g. Here you're picking up g and plugging it into f. And one of the ways to remember this is you always start on the back side of these. It's the one place where we seem to work from right to left. So this is the function I'm going to pick up, and then I'm going to plug it into f. This is the function I'm going to pick up and then plug it into g. So, okay, why do we need this in the real world? Well, we've already seen it with the farmer and the fencing when we picked up the perimeter function and plugged it into the area function. The example I like to use is money exchange. So in other words, if you're doing traveling between many different countries where you have to exchange your money. So if I go from the US over to Paris, I need to trade my American dollars for the euros. Once I'm in Paris, if I then decide to go to London, London doesn't use the euros, they use the pounds. So I would have to take my euros and trade them into British pounds. So the composite function would take my dollars and turn them into pounds immediately without having to go through euros. So we do use it quite a bit in the real world. So it's not something unheard of. So let's start evaluating some. You do some of this in that 101 course, so it shouldn't be totally new to everybody. So we're gonna let f of x be x squared plus 4. And g of x is equal to 5x. So I have two functions, x squared plus 4 and 5x is my second function. So I want to find each of the following. So the first one I want to find is, let's go find f compose g of 1. So f compose g of 1. Okay, so we said just a few minutes ago, this is where we're going to work backwards on this. So the first thing we're going to do is the tail end of this, the right side. So we're going to go figure out what g of 1 is. So I'm just going to find g of 1. So g of 1 means plug 1 into g. So that would be 5 times 1, which is 5. Now I'm going to take that. That's the output of g, and I'm going to use it as the input into f. So now we're going to take all of that and plug it into f. So now we'll find f of 5. So that output becomes the input into f. So f of 5 would be 5 squared plus 4. So that's 25 plus 4. or 29. So f composed g of 1 is equal to 29. So that's the only difference. So you're now layering your functions, and that's it. Let's try another one. How about g compose f? Also of 1. So now we're going to compose them in the opposite direction. So the first thing we will do is find f of 1. So f of 1 would be 1 squared plus 4, which is equal to 5. And then we're going to take that output and plug it into g. So now we're finding g of 5. So that would be 5 times 5, which is 25. So notice we get two different answers. One way when we composed it, we got 29. The other way when we composed it, we got 25. And I don't expect the answers to be the same. I do expect them to be different. Okay, any question about the order that we're plugging things in? We're all good? Looks like we're good. Okay, let's do a couple more, just a little bit different. Same two functions. We're not done yet. So part C. We're going to go find f compose f of -2. So f compose f of -2. What? So again, we'll start on the back end of this. We're going to find f of -2. So that would be a -2 squared plus 4. That's 4 plus 4, which is 8. And we're going to find f of 8. So again, the output from the first evaluation becomes the input to the second one. So then we would have 8 squared plus 4. I'm plugging it back into the same function. 8 squared, 64 plus 4, and we'll get 68. Okay. Any comments or questions about that?
No.
Okay. Then you're going to have, and this is actually the first problem on the homework, they're going to give you a table of values. So for instance, and this takes a few minutes, the top line is going to be the x, the input value. Our next line is f of x. And our next line is g of x. Okay, so we've got -3, -12, and 9. That is a 12. The next column is -2, 9, and 4. The next column is -1, 6, and 1. Next column is 0, 3, 0. The next column is 1, 0, 1. Our next column is 2, -3, and 4. And then our final column is 3, -6, and 9. Okay. So we don't know what the functions are, but we do know that when we plug in a -3, that f of -3 gives me -12, that g of -2 is 4, and so forth. So what we're going to do is use this table to find each of the following. And the first one I want to find is f composed g of -1. So f composed g of -1. So it's the same thing we were just doing, but they're giving me a table versus having to evaluate the function. So again, the first step is to find g of -1. So I go to my table, I go to an input of -1, I go down to g. So g of -1 is 1. That then becomes the input into the f function. So now we're going to find f of 1. So f of 1, I go and find my x value of 1. F of 1 is 0. So the end answer is that 0. Okay, let me walk through that again just to make sure everybody's got it. So the first thing we did is we found g of -1. So I go to where I have an x of -1. I go down to my g and see that the output is a +1. That becomes the input into f. So we're going to find f of 1. So I go find an x value of 1. I go into f and see that f of 1 is 0. So once you get the hang of it, it's really quick and really easy. They're nice problems to do. Let's try another one. How about g compose f of 0? So g compose f of 0. So what do I need to find first? F of 0?
Yes.
Okay. So what is f of 0?
Three.
Yep. So f of 0 is equal to 3. And then what are we going to find second?
G of 3.
Yep. Beautiful. So g of 3, when we go over to 3 and follow it down to g, is 9. Nice. Okay, one more of those. Let's do g compose g of -1. So g compose g of -1. Okay, so the first step is find g of -1. So g of -1 is 1. We already did that. And then you're going to plug that back into g. So g of 1 comes out to be 1 also. So our end answer is 1. So we've done composites, evaluating from a table and then evaluating from the actual function. So far so good. For a Monday morning, right? The beginning of our 9th week of class. Okay, so now what we're going to do is start composing actual functions. So this time, let's let f of x be x squared plus 2x minus 4. Oops, no, plus 4. And we're going to let g of x be 2x minus 1. So f of x was x squared plus 2x plus 4. And g of x is 2x minus 1. Okay, what I want to do is I want to find f compose g of x and its domain. So I want to find f compose g of x and its domain. Now we haven't talked about the domain yet, so we'll have to do some steps for that. But let's go tackle the f compose g part of the function or the equate problem first. Okay, so this time what we're really doing, again, we're finding f of g of x. So notice I've elected to write it in the other format. So this would be f of, and now I'm going to take and put in g of x, 2x plus 1. So we're really just plugging 2x plus 1 into our function in place of that x. So every place I have an x in my f function, I'm going to write it 2x plus 1. So I have 2x plus 1 squared plus 2 times 2x plus 1 plus 4. So every place we had an x, we wrote a 2x plus 1. You are expected to clean this up. You can't leave it like that. And the cleanup's actually the longer part of it. So I have 2x plus 1 times 2x plus 1. I need to FOIL that out. So let's go ahead and FOIL that out. We'll get a 4x squared. The outside and inside term are going to give me another 4x. The last term would give me a 1. So when I FOIL out that 2x plus 1, I get 4x squared plus 4x plus 1. Now we'll distribute the 2. That'll give me another 4x plus a 2. And then plus the 4 at the end of that. Collecting like terms, we're going to have a 4x squared. My 4x and 4x gives me 8x. 1, 2, and 4 is going to give me a 7. So when it's all said and done, the composed function is 4x squared plus 8x plus 7. Okay, for this one, to find its domain is actually not that ugly. So the domain of the composite function in this case is simply going to be all real numbers. And why is that going to happen? Well, if you take a look at it, the domain of the original function, that's a parabola. You can plug any number you want into a parabola, a quadratic. The other one's a line. Its domain is also all real numbers. So their domains have no restrictions. So the domain, when you compose them, has no restrictions. So because there was no restriction into plugging into G or into F, there's no restriction plugging into the composite. That's a little strange. And we'll do some that are a lot uglier, and we'll have to do some steps on those. Comments, questions about finding F compose G?
No, I'm good.
And because of where we're headed tomorrow, let's go find G compose F and its domain. So this leads right into tomorrow's lecture so nicely. So now we're going to find, for the same two functions, G compose F of X and its domain. So now we're finding G of F of X. So I'll go back to the older notation. So this means we're finding g of x squared plus 2x plus 4. So I'm going to pick up all of f and plug it into g. So that would be 2 times x squared plus 2x plus 4. So I simply replace the x with all of f, and then I have that minus 1 afterwards. So that gives me 2x squared plus 4x plus 8 minus 1, or 2x squared plus 4x plus 7. So a distinctly different looking answer than we got the first time. It is still a quadratic, but it's a different answer. And then its domain is still going to be all real numbers because neither of the original functions, either f or g, had any restrictions. So there's no restrictions on the domain when I compose them together. In other words, I can plug any x value I want into g, any x value I want into f. So I can plug any x value into their composed function also. So it's a nice straightforward one, not a lot of hidden anything. Let's go try another one. So now the functions are going to get uglier. So let's let f of x be 1 over x plus 2, and g of x is equal to 4 over x minus 1. So f of x is 1 over x plus 2, and g of x is 4 over x minus 1. Okay, so same exact thing that we did last time. The first thing we want to do is find f composed g and its domain. Okay, a lot uglier. So again, what we're finding is f of 4 over x minus 1. So I'm simply plugging g into where we would plug in the x. So that's going to give me 1 all over. And now in place of my x that's in f, we'll plug 4 over x minus 1 plus 2. So all we did is replace our x with the 4 over x minus 1. Unfortunately, you, of course, can't leave it looking like that. You need to clean that up. So what we're going to do is we're going to treat this 2 and put it over a 1. And then we're going to do what I call as a cross-multiplying product trick to clean up this denominator. So again, what I'm using, my trick, that you will use a lot in pre-calculus if you move on, is if you have a over b plus c over d, that's equal to a times d plus b times c. So that's the cross-multiplying. But then you have to put it over the denominator that's common, which would be b times d. So it's a cross-multiplying product trick. Well, we're going to do the same thing. The numerator is 1. In that denominator, I'm going to take this 4 times this 1. So that would be 4 plus 2 times the x minus 1 all over the product of the two denominators, which is x minus 1 times 1. So what we're doing is creating a common denominator without having to go through all of that. Okay, I'll walk through it again. So I took 4 times the 1 plus the 2 times the x minus 1, and then put it all over the x minus 1 times 1. Any comments? You probably have not done that before. I don't know. I'm guessing. Okay, we need to clean it up. We're still not done. So that gives me 1 all over. I have 4 plus 2x minus 2 over x minus 1. So that's going to be equal to 1 all over, let's see, 2 plus 2x over x minus 1. So all I did is combine my 4 and my minus 2 together. Okay, and then if you remember way long ago in like 5th grade, when you started working with really fractions, you have a whole number being divided by a fraction, so that's really multiplied by the reciprocal. So this is 1 times x minus 1 over 2 plus 2x. So our final answer for the composite function is x minus 1 over 2 plus 2x. And there it is. So that's the end result of F composed G. So that is F composed G. Okay, any questions or comments? These are some of the ugliest things we do. If you can get through this, it really is all downhill. Okay, now we have to find its domain. So I'm going to leave that there because I need it. I'm going to come back over here. This time we're going to run out some steps. And the reason we need the steps this time is because you have restrictions on the domains of those two functions. So because we have restrictions, we have to go through some steps. Okay, step one, we're going to find the domain of the input function. Find the domain of the input function. So for this particular one, the function that we picked up and plugged in was G. So G was the input function. So the input function this time was G of X. Okay, its domain is what? Well, what number can I not use in the bottom of G? What number blows it up and causes issues?
1.
1, beautiful. So X can't equal 1. Now, normally I would write that in interval notation, but we're not to the final step yet, so we're going to keep going. Okay, step 2, we're going to find the domain of the output composition. So in other words, the function we just wrote and came up with as an output is what we need to find the domain of. So now I'm going to come in and take a look at this F composed G. So that was F composed G. So to find its domain, we're going to come in and take the denominator 2 plus 2x, set it equal to 0 to figure out what number we cannot use. So that would be 2x equals a negative 2 and x equals a negative 1. So x cannot equal that negative 1 because if it does, then this function has issues. Okay, and then all we have to do is intersect these two steps. So step 3, we're going to combine the two restrictions. Combine the restrictions. And I'm going to do it on a number line because it's just easiest for us. So in other words, we take whatever the restriction was from the first step and whatever the restriction was from the second step, and we're going to combine or intersect them together. So for us, we're saying this. From step 1, we know that x can't be a positive 1, so I'm going to put an open circle on a positive 1. From step 2, we know it can't be a negative 1, so I'll put the open circle there. Those are the only two numbers you can't use. You can use everything to the left, everything in the middle, and everything to the right. So then your final domain is going to be from negative infinity to negative 1, negative 1 to 1, and 1 to infinity. Much harder when they're not polynomials. So the rational functions are definitely more difficult to deal with. Okay, but if you follow these steps, you should be good. These are different than what your book uses, but this will work. So, okay, let's do the other composition. Everybody good with that? Okay. Let's go find the Goff function. So G compose F. And its domain. So the second part, we're going to find G compose F. And its domain. So what we're finding is G of 1 over x plus 2. So we're replacing the x with the f function, which is 1 over x plus 2. So we're going to have a 4 in the numerator. That would be all over 1 over x plus 2. So I've replaced that x with what f is, and then minus 1. And you never leave fractions inside of fractions, so we have to clean that up. We're going to put that 1 over 1, so we can do that cross-multiplying product trick again. So it's going to give me 4. I'll have 1 times 1, which is 1, minus 1 times x plus 2. All over the product of the two denominators, which is x plus 2 times a 1. So again, I do this times this. I pick up the sign and do this times this, and then put over the product of the two. So that'll give me 4 all over 1 minus x minus 2 over x plus 2. Still cleaning up the denominator, that's 4 all over, negative x minus 1 over x plus 2. And now we'll do the multiplying by the reciprocal. So we'll keep the 4. And we're going to multiply it by the reciprocal of our fraction in the denominator. So that's x plus 2 all over negative x minus 1. So our final step, we have 4 times x plus 2 all over negative x minus 1. You can distribute in the 4 if you want, it doesn't matter. The numerator is not going to impact anything from here on out, so I tend to not multiply if I don't need to. Okay, so that's the composite function. That is G compose F. That's our Goff function. But now I need its domain. So now we're going to follow those same steps. This time, the input function is f of x because it's the one we plugged into the other function. So it's the one we picked up and used. So its domain was that x couldn't be equal to what? Negative 2? So notice that the input function adds a different restriction this time. Step 2, we take a look at our output. So that was the answer we just got, the G compose F. And from that denominator, be really careful with your signs. If we take negative x minus 1 equal to 0, then negative x equals 1 and x equals a negative 1. So very careful about your signs. No sloppy mistakes. Okay. Okay, so x can't equal a negative 1. So on our number line this time, we have a negative 1 and we have a 2. They're both open circles, and you can use everything else. Now, it's a fluke that we got a negative 1 out of this and we got a negative 1 out of the other one. That usually does not happen. It's just a fluke. Doesn't always happen. So our domain is going to go from negative infinity to negative 1 to 2, and 2 to infinity. And that's your function. So we found our Fogg function, we found the Goff function, and the domain of each. So how do we feel about them when they're uglier functions? Are we okay with those, or do you want another example involving a square root?
I think I'm okay.
Okay. Okay. Yeah, you did composite functions in 101. These are uglier composite functions, and you didn't worry about the domain then, but you have done this kind of manipulation before, which is nice. Okay. So the next examples are going to ask us to show that F compose G is equal to G compose F, which is equal to X. So that's what the directions are asking us. And what we're going to do is we're going to let F of X be 2x minus 6. We're going to let G of X be 1/2 times the quantity x plus 6. So F of X is 2x minus 6. G of X is 1/2 times the quantity x plus 6. Now, looking at both of these functions, they're both lines. They have no exponents, no radicals, no x in the denominator. These are lines, right? This doesn't mean anything today, but it will tomorrow. So, okay, let's just come in and compose them. So we want to go find F compose G of X. So that means I'm going to pick up all of this and plug it in for that x right there. So I'm going to have 2 times a 1/2 times an x plus 6 and then a minus 6. So again, all I'm doing is replacing this x with all of that function. And now you're just cleaning it up. Well, the 2 times the 1/2 is going to leave me with just 1. So that's x plus 6 minus x, which is equal to x, which is what they said would happen. F composed G is x. Huh, well, that's different. Hey, how about G compose F of x? So now we're just going to compose the other way. So this time, we're going to pick up, I'll tell you, these markers, all of this, and plug it in for that x right there. So that would be 1/2, and then in parentheses, in place of the x, we'll have a 2x minus 6 plus 6. So I'm going to do what's inside the parentheses first. The -6 and the +6 are going to cancel and just leave me with a 2x. Then the 2 and the 1/2 would cancel and leave me with just x, which is what they told me would happen. Huh, well, that's different. Does that happen every time? Well, no, because we've already done multiple composites where this didn't happen. It does happen in a special classification of functions that are inverse functions, which is tomorrow's lecture. I would like to point out the order in which things canceled. So when we did F composed G, we canceled the 2 and the 1/2 first, then we canceled the 6's. When we did G compose F, notice the 6's canceled first, and then the 2 and the 1/2 canceled. So they kind of canceled each other in the opposite orders, depending on which composite we were doing. So you're going to have, I think, 2 of those on the assignment. They're pretty straightforward. Not bad at all. And then the final problems are what we call decomposition. So we've been composing. Now we're going to decompose. So decomposition. One of those big words we get to use, decomposition. So D-E-C-O-M-P-O-S-I-T-I-O-N, decomposition of functions. In other words, they're going to give me the output, the composed functions, and we have to go find the 2 functions that it came from. So we want to find functions F and G such that F composed G is equal to H. And what they're going to start off with is something like this. They'll give me H of X is equal to the square root of 3x minus 2. So in other words, I've composed 2 functions together. And when I do that, the result is the square root of the quantity 3x minus 2. Okay, well, what I like to do with this is we're going to let f of x be the outside. We're going to let g of x be the inside. And it's really easy to see the sum square root because you can see the outside and the inside. So in other words, I'll start with g of x. The inside is 3x minus 2. The outside is the square root, but because you have to have something to place or replace into, we're going to just call it the square root of x. So what I'm saying is if you let f of x be the square root of x, and you let g of x be 3x minus 2, then when you take and compose this into that, the 3x minus 2 in for the x, don't we get h of x? So we're simply pulling it apart into its 2 parts. I could have also done, so notice that answers will vary is what the textbook tells us. We could have done, so this is a big or, we could have said let's let f of x be x minus 2, let's let g of x be just 3x. In other words, I can take this 3x and plug it in for that x, and it'll end up right back up here. So there are multiple answers. There's not just one answer. You can do it a couple of ways. Okay, and that's everything that's in that first section, section 6.1. So any problem composing the functions, plugging f into g or g into f?
And just the fractions, but I think we'll get through it with practice.
And it is going to take practice. It is also not necessarily a short assignment because of those fractions. The radicals are not bad. It's those fractions. So yeah, If you have any problems, let me know tomorrow. But I urge you to try and get it started today if you can. That way you're kind of on top of it for tomorrow. So I did get your R3 review to dates graded. I emailed them back to you this morning, so you should see your graded work. You can look it back over. And I did transfer all the grades into Blackboard. I went over the quiz, gave back some partial credit, and put those into Blackboard. So the Blackboard grade is up to date also, okay? So don't forget to go do a discussion problem. Rich, Matt, okay? Any other comments or questions?
No, that's
Okay.
it.
Okay, have a great day. Enjoy your Monday.
You too.
You too.
Too.